Good afternoon. Welcome to day 2, video 1. In this video, we're going to look at a telescopic series. Now, we've already looked at a geometric series, and now we will look at a telescopic series and find when that telescopic series converges. Well, all telescopic series converges. So if it's telescopic, it will converge. It's just a matter of finding the sum to which it converges. A telescopic series is in this form. Now notice I'm using partial fractions. What I did here was I used partial fractions to rewrite this expression. And to recall, partial fractions is where I did a over n plus b over n plus 1. And when I did that, I found that a was positive 1 and b was negative 1, which gave me the second expression. So what I'm doing in this telescopic series is I'm evaluating numbers for n. So this is when n is equal to 1. So when n is equal to 1, I get 1 divided by 1, which is 1. And here, when n is equal to 1, I get 1/2. This is where n is equal to 2, so I get 1/2 minus 1/3. This is n is equal to 3, and I get 1/3 minus 1/4. I want you to notice what starts to happen here. Notice I have negative 1/2 and positive 1/2. And what does that do? Those two terms will zero out. 1/3 and 1/3 will zero out. However, and so that will continue. So the next time I do this, I'll get 1/4 minus 1/5. And you can see that the 1/4 will start to collapse. So we say that our sum then is 1. So the telescopic series converges to b minus 1 minus the limit of infinity of b over n plus 1. Generally, I just find the different terms and collapse them. That's what I do. I normally don't use this formula, but there it is. Okay, so a telescopic series will always converge. When it converges, this is its sum. But I generally just use collapsing it and find the sum. So here's an example. This is in your notes. This is page 4 of your notes at the bottom. There are 2 problems at the bottom. We're only going to do 2 problems like this. By the way, although this is not on the AP exam, but before you stop the video, it is on your quiz. On both quizzes, you may find this. So it's important that you know it. So I'm going to use partial fractions to rewrite this. So then I get 1 is equal to a times n plus 2 plus b times n. Then if I said n equals negative 2, I get 1 is equal to negative 2b, and b is equal to negative 1/2. If I let n equal 0, I get 1 is equal to 2a. So I get a is equal to positive 1/2. So I'm going to rewrite this as a is 1/2, b is negative 1, it's 1/2 over n. b is, oh, that's an ugly fraction, there we go. b is negative 1/2 over n plus 2. Now, to find the values for which it collapsed, I just find values of n. So I'm going to start when n is equal to 1. I get 1/2, because I'm just plugging in 1 into this expression, so I get 1/2. If I plug in 1 into this expression, I get 3/1/6. When n is equal to 2, I get 1/4 minus, that's 4/8. So it doesn't look like anything's collapsing. Hopefully something will collapse soon. So when I do n is equal to 3, I get, oh, look at that, positive 1/6 minus 3, so that's 5 1/10. Let's just do it again for good measure. If I do n equals 4, I get plus 1/8 minus 6 1/12. Okay, so let's see, how does this collapse? We see the 1/6 zeroes out, the 1/8 zeroes out, and I could see that over the next one I would get 1/10. When I plug it in 5, I'd get 1/10, so I would see that that would collapse. What will not collapse, well, I'll never have another 1/4, because if you notice, these are increasing. So I'll never have another 1/4. So my sum is 1/2 plus 1/4. And that's my sum. Okay, let's try one more. Now for this one, it's going to take a little bit before it collapses. If I were you, I would pause the video, I would try it on my own, and then come back and see what happens. Welcome back, because I know you paused this and did this on your own, and you're just so anxious to see what happens. So we get 4 is equal to A times n plus 4 plus B times n. We're going to let n equal -4, and we get B is equal to -1. We're going to let n equal 0, and we get A is equal to 1. So I have 1 over n minus 1 over n plus 4. And that should be my hint that something's going to collapse. So I'm going to start with n equals 1. When n equals 1, I get 1 minus 1/5. When n equals 2, I get 1/2 minus 1/6. When n equals 3, I get 1/3 minus 1/7. Still no collapsing. Let's try again. When n equals 4, I get 1/4 minus 1/8. Still nothing. When n equals 5, I get 1/5. Oh, I finally got something. 1/5 minus 1/9. Okay, so I'm starting to see that it's collapsing because I have -1/5 and +1/5. Let's do another one. Let's do when n is equal to 6. I get 1/6 minus 1/10. Okay, so I start to see that something is collapsing. So I see that the 1/5 collapses. Notice that these values are increasing. I have 9, 6, 10. So this value will never go below 6 again. So anything that is below 6 is going to remain. So 1/7, if I go to the next one, 1/7 would zero out, and the next one, 1/8 would zero out. But what will never zero out is the 1, the 1/2, the 1/3, and the 1/4. And so the summation of that would be 25 over 12. You can do the math on that if you like. So that sum would equal to 25 over 12. Okay? That's telescoping series. Once again, it's not on the AP exam, but it will be on your first test. And you will have homework on it as well. So thank you for watching video 1. Please watch video 2.